Sammy, can you see the people who are trying to join? Just confirming.
Yes, I can. I just admitted
Oh,
some.
okay. All right. Thank you very much. Thank you. Thank you for that. Okay. So I'll be leaving in a bit, like I said. So please,
Problem.
I think I would leave it in your hands, you and Abdul. Thank you so much.
You're welcome. So it's a wonderful time to be here again. I'm happy to go over the data wrangling as discussed in our last lecture. And today, for the benefits of those people that were not in our last class or just joining the lecture for the first time, I will quickly just go through what we have done. Let me share my screen. Now, this is what we do normally. Whenever you want to start, and we are using Google Colab, the major thing you do is just to go to your browser, preferably your Google Chrome, and type Google Colab. So when you type Google Colab, it brings you here. And then you look for Google Colab. Then on the Google Colab, since you just want to open a new notebook, you just go to new notebook. If I say open Colabs, it's going to take me to what I've done here layer and that are stored inside my Google Colab. But I just want to open a new notebook, starting afresh. So if you are just joining, this is where we'll be coding. Now, when you get here, you're gonna see it like this, and this is what we call shell. So in the shell, you can make the shell to be more than one. You just have only one shell. You just come to this code and continue to press the code. It will increase the number of shell we have because we're gonna be coding inside the shell. So this is the normal thing we have been doing. So if you are here already, then we can continue coding together. So this is the platform we are going to be using to code. Now, before this time, these are the major things we have done. We have done when we have a data, the first thing we do when we have a data is that we import necessary libraries or we install the necessary libraries. After the installation, we import the libraries, and then after importing the libraries, one of the first thing we do is we read the file, the data we want to use. In case the data is can be on our system in a file in form of CSV file, in form of Excel, so we can easily read them. It can be in form of JSON. At the same time, we may not have the data. We may have to read from URL, get it from a website. We can also scrape a website using beautiful SOAP libraries if you are using Python, and etc. Those are the things we can do. But now, for now, we only want to be reading from file, a CSV file or a SF file. Now, after the data has been read, one major thing that we can do, we can check for the data shape using this method, checking the shape of the data. Another thing we can do, we can check for the type. But even before then, we can as well do all this. Do the data add, also the data, we can do the describe for the data. We can also do info for the data. So these are things we can do. And after that, we can also check the shape. But even checking the shape, we may not necessarily have to do that, because at a point when we are checking the describe or the info, we can get the shape from there. Another thing we can do, we can check the type, but even checking the info, we can as well know the types of the data we have in our data frame. Then after that, we can check for the norm number. We can check for the norm that we have in our data. At the same time, we can drop unnecessary column. So if we have any column that is not useful, we can just drop them. If we have other columns that they are useful, but we have to rename them, we want to rename them, we can use this a method to rename the column. For example, I have a column that is too long, I can rename it and just reduce the name. At the same time, after checking the name, we can change the data type. If there is any data type that we don't is mismatched, then we can change it using this method. Although this is not the only way to check to change data type, we can use some other method, but this is a common one we can use. After that, we can check for missing data. Oh, okay, we have checked for the missing data using for the NA. This NA is checking for the missing data. But when we check and we have some missing data, we can look for a way of inputting or handling the missing data, either by inputting or deleting, and so many other things we can do on them. We have discussed this at large. At the same time, we can also check for, we can also undo outliers in our data. We know what outliers are. Outliers, they are part of our data set that, please, I think this place is dark. Let me quickly change the. Oh, thank you. I just on the light. So we can undo the outliers. I'm just talking about outliers. They are just abnormal entries in our data. For example, you checking the age of student in year 7, and it is expected to be around maybe 11 years to 13 years, I don't know. And now we are now getting a year of 30 years in that year 7. We know that is going to be an outlier. Another outlier can be even below. For example, in year 7, you are having a 7 years old in year 7 is going to be an outlier. It's supposed to be between age of 11 to 13. So these are things we are normally going to do whenever we have any data we want to talk about, or we want to claim or manipulate. So these are the common things we do. Apart from this, we can also do encoding. Yeah, we can also encode. For example, if you have a set of categorical data, for example, we have like gender, and we are saying male, female, male, female, female, male, we might decide to say, okay, let every male be 1 and let every female be 0. Or if you have yes or no, we may encode to have yes to be 1 and no to be 0, because there are some machine learning model that will work better with numerical rather than working with giving us a better accuracy with numerical rather than categorical. So because of that, encoding will be necessary. Anyway, you have, for example, we have temperature, and in the temperature column, we have something like high temperature, maybe medium temperature, and the low temperature. And then we can look for a way to encode. For low temperature can be 0, high temperature can be maybe medium temperature can be 1, and low temperature, high temperature can be 2, like that. So there are so many methods of doing this. Either we use encoding, or we use dummy, or we use mapping. So that is going to solve this problem converting categorical to numerical data. But this will best be understood when we call for a particular data and we try to do the necessary steps. So the first thing we do, we import the necessary libraries that we use. In our last class, the library used, let me just go to the last class and copy the libraries. These are the libraries we use to the new one. Okay. These are the libraries that we are going to import. We import NumPy as NP, we import pandas as PD, we import matplotlib .pyplot as PLT. We also import Seaborn as SNS. So these two are meant for plotting a graph, charts, visualization, different type of visualization. Why these are meant for data frame and data frame manipulation. If you want to be dealing with machine learning model, there are other libraries that we're gonna import for that, but it's not yet time to go into any model. So these libraries are sufficient for now, for the little wrangling we want to do. So now after that, I will have to bring up the data I want to use. And this is the data I actually want to use. These two data, the train data and the variable explanation. So those are the data we want to use for today. We are not going to use the test for now, because the test is actually when we have built a model, we can use the train to train the model and use the test to test the model, the performance and stuff like that. So imported, I have my data. After I have my data, the next thing
Wait, sorry, I was just following along. So what did you just do to import it? Did you go from file?
the data, right?
Yeah.
Yeah, you click this file. Okay. You see this folder here. You see the folder? Hello?
Oh, sorry. So I'm like, yeah, I see it.
Yeah,
I see
you
it.
see this logo?
Yes.
This folder logo.
Yep.
When you click it, it's going to bring you here where you see something like upload.
Upload.
So you now click the upload. The upload, you should know where the data is on your system. So the data has been shared with you. You download it. Possibly it's going to be under download. So you go there and pick and click the data. It's going to import it into your Google Colab. So after you have done that, then you can bring up this code. You can type this code. There are two data. Or actually, I share 4 data with us, but I will be using the variable explanation data and the test train data. Okay. So you'll see, if I click here, I already have these two data. And the name of the data I want to bring up is variable explanation.csv. You can see it is here. And sometimes it is better for you to just copy the name if you know you are going to not going to be able to write it correctly. Because if it's different from what you have here, you will never be able to import it. So what you can do is to just come to this three dots you have here, this three dots. On the three dots, you see copy path. So when you copy the path, you come and paste it. And then, oh, I already copied train, then you just clean up the remaining part. This name is the only thing I need. If it is this one, you come here and you copy part. I don't know why it's not okay. I want to set I can't set it, I don't know how. Anyway, so when you're going to type the name correctly, so you will be able to import it. So after typing it, you run the shell. This is where you click to run the shell. So running this shell, oh, PD is not defined. Okay, I didn't run the first shell. I have to run the shell. Import, so I have to import it. I run the shell, it has been marked. The other one, once it's not marked, it means you didn't run the shell. So now that it is marked, then it means I've run the shell. So I run this other one, and the shell has been, this has been run. Then now I can call this data to know what is inside the data. When I run it, this is what is inside the data. It's telling me that these are what I have. The first thing is this, and this is what it means. The second thing is this, and this is what it means. Survey date, this is what it means. Age, this is what it means. So it's only telling me the columns that I have about 75 columns in my data. And those 75 columns, they have their description. In the column, anywhere I see day of week, this is what it means. It means days of week of survey. That is when the survey was done. Anywhere you see yearly survey, this is what it means. Anywhere you see amount saved NPESA, this is what it means. So in case if you see them in your table, in your data frame, and you don't know what they mean, just go back to this file, you're gonna know the meaning. And there are some that are hidden between 4 to 70. If you want to see that, there is a code you can use, but instead, you can as well just say, for column in this, print the column. But if you don't still want to do that, you can use these will run in our last class. So if I put it together with it, it's gonna run everything for me. So let me just do this and rerun it. Let me rerun this. You will see it's going to list everything from the beginning to the end. So this is what I got. Please, are you with me?
It's
Yeah.
still right. Sure.
Yeah.
So this is all what we got from the beginning to the end. We got the description of what we are going to meet in our data. So this data decided to put all the description at one place in one file, and the other and the all data in another file. There are some description that will be in the file together, but this one is just like this. So you get the description. We don't need this particular file. We only need it to know the meaning of what we are going to see in our table. So anywhere you see cons alcohol, this is what it means. It means maybe the amount spent on alcohol either per month or per year, I don't know. And this one comes own food owns production in USD. So this is just the description of all our columns. So by the time you go through it, when you see anywhere you see med expenses, SPEP, this is what it means. Medical expenses per episode, spouses, and like that when you go through them. So we only need this to understand what we're gonna mean in our data. But now, since we already have an idea of what we have in our data, let's go and import the data itself. And the data itself is the train data. So the data is the train data. Let me just let me just copy this code. We already did, we have already done all this in our last class. So this is the train data now, and we decided to call that data the head. Unlike the other one, we call it the head ESP. We call it maybe the head explanation, the head explanation. So, but this is the major the head itself, which is in the train data. So if I run this, I will no more be calling the head explanation because I don't need that for now. I only need it to understand my code. But since I now understand what I'm going to meet in my data frame, so if I run it, I get the data frame. So this is the data frame itself. And this data frame is having from this now we're having about 1,142 rows, and we have 1,142 rows, and we have 72, I think 74 columns. We have 74 columns. Where are the columns? If I run this up, we're gonna get all the columns. But we can as well just call for the head because this is just too much. Let's just run for the head. The head dot head. That is only the 5 rows.
Can I quickly ask about the set the options?
Yeah.
Yeah, can I just see how you did it again?
Okay. These options, right?
Yes, that's the one.
These options are not even necessary. It's only telling us that let us see all what we have in the column and in the row instead of breaking some columns for us not to be able to see. So we run that, but not even a good one. It's not always a good one to use. But because we just have to see them, I decided to run that. But if not for the purpose of the class, I'm not going to use that. So this is the data, the first 5 rows. And these are the what we got from data explain, where we have all the column explained. So you're gonna see all these things in the columns now. So this is what it means: sub ID, village, sub date, and familiar. Is it familiar? Familiar? I don't know. It looks like something French. Age, married, children. If you want to know what all this means, then you have to go back to the first file we ran. So if you go back to the first file we run, you will understand what all this means: household size, education, household children, household total numbers, consumes non-durable, assets, livestock. If you want to know what all these assets, phone, if you want to know what they mean, you go back to that data explanation. You will understand what all these things mean. So, and this is about this is 74 columns. But if you want to know, we say one of the first thing you can do is to run the have dot shape. So you want to know the shape, you run this. So if you tell us, oh, it's not having the bracket. Yeah. So it's telling us we have 1143 rows and 75 columns. This is what we have. 1143 rows and 75 columns. The first one is the rows is easier for us to quickly check from here. Oh, not from here, from the entire data. If you check it, the entire data, if you just scroll down, you will get the number of rows, which must be the same thing as what we have here. I don't know what is wrong with my Google Colabs. Maybe the system needs to be restart, but definitely not now. So we have 1142 rows. And if you go and check, you will see should be 1142 rows. Oh, 1143 rows. Okay, together with the okay, 1142, because the index is going to start from 0. So if the index starts from 0 and we have 1143, 1142, automatically it's going to be 1143. That is the shape. So these are one or two things we can do. And earlier we say the things we can do is to check for the head, which we have done. We can also check for the tail. The tail is just the last 5 rows. When you call for we have called for the head, we can as well call for the tail. So if we want to call for the tail will be giving us the last 5 rows. These are just inspection for us to just know, have an idea of what we have in the, let's see, the head, the tail. So we run the head of tail. Oh, so when we run the head of tail, these are the last 5 rows. So the same thing, you can just check through the last 5 rows, okay? And even now, before we continue running anything, you can see that there are lots of data that were not filled. Like this one is not filled. That is why it's NaN. They are not filled during the time the data was collected. So all these things were not filled. So we know we have a lot of NA values that we're gonna see. And at the same time, we can as well check. We have irrelevant data here. I can see this is gonna be irrelevant. There is nothing. I don't need the ID of my the people that answer the respondents. I don't need their ID. The village code. Maybe this is just something like the code for the village. For example, if this were to be a UK, maybe the London is number 3, Bournemouth is 54, Liverpool is 104, like that. So I don't need it. I don't need them. There are some cases maybe it may be relevant if you actually want to know, depends on the goal of what you want to do. You want actually to know how people responded from different village or from different city. So you want to know how many people are from this 152, how many people are from 104, how many people are from 54. So it may be relevant in some cases. I can see this is also not relevant to me. Survey dates, I don't need it. Of course, this only if I want to know how many people responded January 1961, number of people that responded February or stuff like that. So, but for now, I don't need them. So I just have to remove all this one from my data, I know I will have some things to remove. Age, female, okay. If I have one here, it means all this thing is telling us that everyone here, they are female. So if I see 0, it means that person is not a female. So it's gonna be a male. I think the data is good like that. They have tried to help us to do the encoding in a dummy form. So they have done it, 1 represent female, 0 represent male, and like that. Age, you can have someone that is 36 years old, but you cannot have someone that is 36.0 years old. So it means I will have a problem with this age. Age should not be a float. Age should rather be an integer. So it means this age, we have a data mismatch. So the data is not properly matched. Like the age should not be a float. We're gonna know when we check the info. But even from this inspection, I can see that there are some things wrong with this data. Married, yeah. It means if you are married, well, conventionally, if you are married and you say yes, then it should be 1. So if you say no, it should be 0. That is conventional. So that should have also been explained in the description of the data. But if it is not explained on well, we just reason that 1 represents yes and then 0 represents no. Children, number of children, good. From 0 to 100, as many children you want to have. So like that. So these are the data we have. However, there are some of these data that will be mismatched and that we have to correct. Example is the age. We have seen the age should never be in float. The age should be in string. So we just check across, but we have a big problem with NA. You can see NA everywhere. So we have to clean this data with NA. We have to clean everything. So after that, after we have checked for this, so what is the next thing we can do? The next thing we can do is let's just say what we did in our last class. So that's okay. Let's follow the convention now, because I don't see. The next thing we can do, this if you are just joining, you can see I have just only 1 shell left. Please excuse me.
Hello, I have a question.
Excuse me, I quickly want to attend. Just give me 2 minutes.
Okay.
Sorry, I just quickly attend to a family issue here. Thank you. So after you have checked the shape, you can we have checked the shape, then we can do info.
Hello.
The help.info. So this is the info of our data. So this info is telling us that in the data, we have 1143, which have given us, we have 1143 rows. So the rows start from index 0 to 1142. Of course, we can see that from the data. So you can see the index start from 0 and end at 1142. And the old data is 1143. Of course, I told you the index start from 0. And that was why when we check on shape, you have 1143 rows. So now again, we have number of columns. The columns is 75 columns. And someone will just like, if you call on info, you don't necessarily have to check for the shape here. You can see the all information, the info has given us the shape information as well. When you check on the shape, you know that we have 75 columns and then 1143 rows. The same thing is on the info. When you check on info, you can see you have 1143 rows and you have 75 columns here. And it's even telling us that the rows start from index 0 to index 1142. And if you go and check the entire row, you will see that it stops at 1142. But at the end, we have 1143 data because because it's starting from index 0. And that is why we are having 1143. So the info is a very good method because this one we give the whole information about our data. Another thing we can get from here is there is another thing we can check. We can actually check data type, but even without checking the data type of the columns, you can see the data type of every columns here. This is telling me that the survive ID, the data type is integer, the village ID, the data type is integer, the female ID, the data columns, the data type is integer, the age column, the data type is floats, which we can see. And I already said the column being a float is not a good, the age being a float is a mismatch data type. We can see that from our data as well. So all the information about the data type has been given here. And it's also telling us this one is also telling us that we have some missing number because if we have, of course, in our data, we can see NA when we're checking the data, which shows that there are some missing number or missing values rather. When we check here, we can see that some of them has a missing value. Let me check again. If you just go like this, you see NA, different NA. You can see this NA, all this NA. So if you check your info, the info will still tell you that it has NA. This column is telling us that we have 1143. For this, we have 1143. For village, we have 1143. For all this, we have 1143, which is the same thing as the total number of rows. But however, sometimes like this one, it's telling us that we have 809 instead of 1143. We have lots of data that were not reported here. It's supposed to be 1143, which shows that under this column, if you go and check this column, you are going to find NA there. If there is no NA, everything is supposed to be 1143 throughout. But if I keep checking, you will still see more. Here we have 1100, which shows that this is also having NA. This one is also having NA. It is supposed to be 1143, and we have 1123 here. So if you subtract this, you see the total number of NA we have here, and see the NA we have A as well. So say in this one, we are going to have a lot of NA. If this is about 700 and we have about 1001, so we have over 400 NA here under this particular column. We have over 400 NA. So we have a lot of work to do to clean. The same thing here, 2727 and like that. Oh, this is even the worst, I think. This is having 450, and out of 1143, we have a lot. This is only suggesting to us that by the time we get to our NA, it's going to be difficult for us to drop all NA, because if we are to drop all NA, at least if we are dropping all NA, it means all this that is 1143 will come down to 450, and that is if 450 is even the least we can get from there. So dropping NA, and you can see dropping NA is going to, This is another worst case, 265. Then dropping NA is not going to be an option here. It means we are going to drop all our data if here is not taken. So this is giving us a lot about the 54, 59. Yeah, it means this is I think this is a question that I don't think they want to answer this question. You are asking medical under 5 death. If you go and check what this means under our description, it's asking that did they have a child that has died between age of 5, under 5, I think, something like that, in the family? So it's just yes or no. We have children or a child that has died or have died between less than 5 years old. So it's just a yes or no. Maybe some people don't want to answer this question. So that is why we have as low as this. So which shows that we cannot drop NA. In fact, I will even prefer to drop this particular column than to drop NA. I've just removed this from my data set. People don't want to answer it. They don't want to answer this question. So that may be an option. Or I fill everything with the maximum, with the mode rather. If the mode is no, yes, I just fill everything with the mode. Or I just remove it because this may be this data is not going to be because if I'm using 59 to judge 1143, that may not be nice enough. It's going to be it's going to introduce error into my data. So I'm just thinking it would be best to even remove this column as a whole, because that column, the entry is too poor, in my own opinion. So here, whatsoever you're gonna do here now depend on what you think. So, but in my own opinion, I just have to remove that particular column, because we are supposed to get 1143 and we are only getting 59. So it means the column cannot be used to judge anything. So it may be as good as removing it from my data. Okay, this is what info can tell us. Like, okay, we have gotten all the information about the data from just running.info. Good. After running.info and we have gotten all this, the next thing we can do is to check for is to check whether we have NA. Of course, we already know we have NA, but well, it's a normal thing to just check whether we have NA or not. So I'm using the last one to just okay. No, yeah. I think what I am thinking about now is to even drop columns that are identical. Yeah, let's try to see if we have any columns that are identical. Okay, let's go back to this description. Let's go back to this description. If you read this description very well, you will see that there are some columns that are very identical. They mean the same thing. I saw one yesterday while I was going through the column, while I was going through the description. Yeah. Let's see. Which one? Something size, like the number of children. I saw that, and they actually meant the same. It was a question that was asked twice in a different way. Yeah, household size. If you see this particular column, there's another column that also means the same thing with it. total member, household size. Okay, let me see if, okay, see another one. Household size. It means they are asking this question twice. You can see. So I will rather go with either this, is either I go with this or I go with this. I should remove one of them because they mean the same thing. So this thing, the description was meant for us to actually look into it and see if there is anyone that looks the same way. It's like asking question and say, cells, and people feel male, female, male, female, female, female. You now ask several questions again, and later you now say gender. So some people may not answer that question again. I think that was the reason we have so many NA. You already asked for the cells, and later you are asking for the gender. So the same thing happens here. And I think that is not the only one. There is another one. There is another one I saw while I was going through the description. So you actually have to go through the description very well to understand what they mean and to know, to see those that are referring to the same thing. If you are able to see them, then if you are able to see that, then you just remove them from your data and take one. It's different from the kind of duplicate we are looking for. So let me explain. There are two forms of duplicate here. For example, let's look into this. If you have a data that looks this way, sorry, I'm coming. Okay, if you have a data like this, if you have D, okay, let me just say A, B, C, D, like this. Let's run something instead of let's just run something so that we can understand very well. If I have a list, I have a data frame. Let me just create a data frame for example. Let's just make a sample data frame is equals to the have. Okay, yeah, the have dot data frame. Okay, let's just make this an empty data frame. So we have a data frame now that is called sample. Oh, what happened? PD, sorry, I'm using DF. Sorry, remind me. I wanted to say PD. PD.data frame. So I create an empty data frame. And to the empty data frame, let's say I have something I call A, like this. I have A, and the A is, let's make a list. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's have B so that you will understand what we mean by duplicate when you are talking about the duplicate. 1, 2, 4, 5, 7, 8, 9, 1, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I have another one. And it's like this. Okay, let me just call this one C. So let's use this one to explain what we mean. So to this sample, let me just add all those things to the sample. sample. I want to have a heading in the sample that I call A. And the A is equals to the A I have here, this A. And to the same thing, to the same sample. Okay, maybe let me just make it multiple. Okay, let me do it one after the other so that what happened again? A is not defined, okay? Okay, I didn't run this from there. I didn't run it at all. So yeah. So this A is now there. Let me just copy it and put B, C like that, so that I don't want to run everything together, so that we all understand what I'm doing in case you want to do yours. You can as well just map them to make everything at once. But of course, I just want us to understand like that. B and C. Okay, let me just call this one apple. Yeah, so that you will not think apple, ball, and cat. So I want to have all these headings. And if I call on my sample now, the samples will have 3 data in it. Sample with 3 columns rather. So if I run, this is our data. Okay, this is the data we have just created. So it has, okay, already appended. Okay, it's good. I appended A. Now, if you are talking about duplicate, if I call on duplicate on this, it's only going to tell me that this is a duplicate because it is the same thing throughout. This is a duplicate. Is the same thing throughout. Is there any other one that is the same thing throughout? None. So I only have 2 duplicates here, 0 and 1. The 2 are the duplicates. I hope you understand. Hello?
Yeah.
Hello, everyone.
Hello.
Yeah, please
Hello, we're here.
just unmute yourself so that you can speak. I can know you are there.
But yeah.
Yeah, we're here.
Okay. Now, I hope you understand what we mean by the duplicate now. If I try to call for duplicate here, let's see. Okay, no, not this one. Let me call for duplicate on this. And you will see what it's going to tell us. Just want to copy a code. I don't want to stop. There's something I want us to understand so that anytime we are calling on duplicate, we understand what we mean by the duplicate. It is not just like there are some things we will not be able to check on. If you are calling on the duplicate, you will not understand what other duplicate that you should have removed if you don't understand this little one. So let's just the small data rather. So from this small data, you will really understand what I mean by duplicate from the column and duplicate from the column and duplicate from the from the rows. So if I call on duplicate on this data, I just copy and I just we call that one sample. Sample is the name of this data. If I run print the duplicate for me, oh, it's not getting any duplicate. It is in data set sample dot duplicated. Oh, it's not even calling on anyone. You should be able to call this as a duplicate. This, they are all duplicates, this as duplicates. I don't know. Is there anything wrong? Let me run this data. Okay, and go back again and run this. Right, should be seen. In data set, 0. Should never be 0. I have 2 already. This is a duplicate. This is also a duplicate, so it should be 2. I don't know what is wrong with my Google Colabs. Anyway, but this is what I'm trying to get out, but I don't just know why. It should tell me that the sum of my duplicates is 2. Should be able to tell me that, but I don't know. I don't know why it's not telling me the duplicate from that. I don't know. Let me check for a missing value should be 0, but I don't know. So, but this is what I'm trying to explain. It's just unfortunate. I don't know. This is a duplicate here. There's a duplicate here. And there's another duplicate here. So this should have given me 2 duplicates, but it's not considering the duplicate of this A vertically and this ball and cat. This is another duplicate on its own. There are 2 different types of duplicates I'm considering. Those on the horizontal and those at the vertical. If you are considering those as the horizontal, this is what it means. Like the whole row 1 is the same thing as row 0. So that is going to be a duplicate of the horizontal. And the duplicate of the vertical is telling me the whole column A is the same thing as the whole column ball, and it's the same thing, apple, and the same thing as the whole column cat. So we can check for such duplicate in our data. So, but this is just by the way, I only created this for you to understand the nature of the duplicate I'm only checking for. Now, if I want to check for so I have to remove this one for now because that is not the data we are dealing with. I only use that to explain. So now let's go back to the data we are dealing with. So if we want to check on duplicate, we firstly want to check on the duplicate from the vertical and from the row. Do we have any duplicate on the row? And this time around, this is just the air. We are using the air. So is there any duplicate on it? If I run it, there may be no duplicate. Okay, there is no duplicate on the row. It's telling us that there is no any of these rows from the beginning to the end. Like when you come to this and you go across all the rows like this, that are the same. I'm sure it may not be possible because we already have ID. The ID will never be the same. Even if other things are the same, the ID will never be the same. So that means, and another thing is that this is automatically taking the survey date. It may not be possible for you to take the same thing at the same survey date, and sometimes there could be time. If you check this, if there is a time, okay, there is no time here. There are sometimes there will be time, so it's not possible you take a survey at the same time, at the same day, for the same ID, the same individual. It may not be possible. So that is why we may not be able to see anything that will be a duplicated a duplicate on our data set when it comes on the row. But what about on the column? Definitely there could be some columns that where we're gonna have a duplicate value, a duplicated value. So let's quickly check for the column. I have a code here. I'll just copy and let's see if we have any duplicate on the column. So let's see. So I will explain my code. The first thing I want to check is, do we even have any of the columns that are named the same way? For example, the same way we have all these names, village, and we are going to see another one that will still be village, or we see another one that will still be age, and we're still going to be the age. Of course, we know that this and other ones, they are the same, but they are never named the same way. So we actually want to check, do we have any of the columns that were named the same way? So there may be none. Let's run. There was none that were named the same way. That is why you see this place empty. I am only checking, I say, in my DHEF, check if I have a column that is duplicated, the same name, like female, age, maybe after typing age, I want to type something else, I mistakenly still put age. So that was what I was checking on the column. So it says the column is empty. There is none of the columns that were named the same way. And if you go back and check the whole column, they were never named the same way. Now, we still want to check, okay, fine, they were not named the same way. Is there anyone, once they are not named the same way, is there anyone that contains the same data throughout from the beginning to the end? Let's see. So I copy this and I'm checking, do we have anyone that were have the same column, have the same thing throughout from the same column that have the same thing throughout, like the one I was showing us just now. So if I run this, of course, we are dealing with the have. Okay. If I run this, so what I'm saying is that create an empty duplicate column. So if I create that, I now say in the column for I in range of the length of the column. That is, of course, we know the length runs from 0 to 1,000 plus. So I can't recall. So I'm saying check in that range. For I call the range I. Check the length. Of course, you already know how to use the length and range while we were doing Python, basics of Python. Then this is in the column, the F dot column. Of course, you know we can check the F dot column. And now say check it throughout. Now begin to pick them. This is how you try to check two things at the same time. You hold one to check the other one. For example, what you do, you just take maybe the first column and use it to check the other columns throughout and say, okay, take age, use this age, use that age to check okay, let me go back. I can't recall all the columns there. Okay, for example, use this village, just hold this village, go use this village to iterate everything to check if there is anything that is the same thing as village. Okay, so it's going to take the village and use it to check survive, use it to check survey, use it to check age, use it to check everything that is from I to the end. I from 0 to 11 something, 1,100 and something rows. So after that, checking that if there is none, it's going to go to the next one. Pick the next one, use that next one to check everything again. If there is none, go to the next one, use it to check every other one again. Then if they are the same, okay, flag it and say, this is the same, append this somewhere and tell me that these and these are the same. So that is what the code is testing. So, and this is it. It's saying, this is the first one, pick one, okay? Use it to check the other one, okay? And continue like that for all the columns. Now, this is how to check how to index each column. You know, when you want to check the index of your for example your list, we say, for example, we have list and then we check the index like this. You can still remember how we slice it. We say from 1 to 6 to 7 is going to check the list and then check from the list element from index 1 to index 6. 7 is not going to be included. The same thing is what we are doing here. Of course, you know, we can use this and say from the beginning to I, where I stop. And the same thing from the beginning to where J stop. We are only trying to compare so many things here, saying equal if it is equal. That is what that means. But now, the thing we have never seen is this I log. You know, in this one, we are not putting any I log. We just use it directly. We are not saying list.ilog. Yeah, we are not using that here because this is just a list. But anytime you are dealing with data frame, the data frame is now different from list. You use ilog or log. So this, you are going to read more about log and ilog. Anytime you see these two things, is just a way of checking the index, not of the list, but of the data frame. This is the way of checking the index of a data frame. If you are using ilog, you are using the index. But if you are using log, you are using the name of the table. That is the column, the table column. That is when you will be using the log. For example, if I want to use the log, I will be using all these names here in the columns. I will be using, I will say run from log, maybe survive ID to, of course, or maybe from the beginning to the name of the hen. You are going to use the name of the column. But if you are not using the name of the column, it's easier. It's better for you to just run it using ilog, using the index. This is the index we are using. Of course, it's starting from 0 to the end. These are the two things we are considering. Either you use this index or you use this column name. So that is what determines whether you use log or you use ilog. So you go and read more about that, you will understand. Now, from after running that, this is what we get. We get the duplicate column by contents. It's telling us that male first newborn is the same thing as male child check. So we just have to take one of these two. Let's go and check from our data. Let's quickly call the data and see what we have there. The head into head. Let's just call the head. Okay, let's call tail. The head does tail again. Let's see if they are the same. The last 5 rows. Okay, you can even check the last 10 rows and see if they are the same. So, and these are what we are looking for. Male versus newborn. Let's see. You see it? Let me know. And at the same time, male, okay, all of them, they are under male. It's like a male, medical, something. Okay, yeah. I'm getting to something medical. Male child, newborn. Male vac, I can't find it. Okay. Male vac. Okay, I see male vac newborn. It will mean male child. Okay, these two. It's telling us that these two, they contain the same thing. And let's actually check. Oh, you can see they are the same thing throughout. If we go and check the meaning, they may mean the same thing. Medical val, newborn, and medical child. Let's go and check if they actually mean the same thing from our explanation, data explanation table. So before you can run anything, any data wrangling, you have to understand the table itself. Okay, male var newborn and male check. Number of newborn vaccinated. Proportion of child less than 14 getting checkup. I don't know if they are the same, but if you check, okay, number of newborns vaccinated. Proportion of children under 14 getting checkup. I don't think they are the same.
No, I don't think they are the same.
They are not the same. It's just that they have the same value. Like majorly people that make their the newborn to be vaccinated, they actually always do checkup for them. And you will see that those people that did not even bother to do, if you see anyone that is 0, that didn't bother to do, what do you call it? They didn't bother to do and vaccinate their child that's birth, are not likely going to do any checkup on them. So maybe that was the reason why it looks the same. So it looks the same, but at the same time, they are not the same. So I cannot remove it from my data. The only thing I think I can remove from my data now is this one that looks the same. Please, can you remind me anyone that looks the same again? New child or something like that. They are the same, merely checking everything. Can you remind me of that? That was the same the other time. Okay. This household, they are the same. Of course, household, this one and this one. I hope you get that right. HH size and HH total member, they are the same thing. So it's either I'm keeping this and remove this, or I remove this and keep this, because they are the same, even from their description. If you check the description is the same. So I can remove one of these two. It's the same thing. HH size and then HH total members. So it means household size. This one also means household size. So which is the same. So let me just remove this from my data. Let me copy it so that I can remember the one I want to. I want to keep one of them and remove the other one. So now I will check and we see that they are not the same. Fine, they are the same with content, but in meaning they are not the same. It means I cannot still remove it, even if they are the same by content, but in meaning they don't mean the same thing. So I can't remove it. So let's quickly remove those things we can remove by dropping. Let's drop those columns we think that needs to be dropped. As for me, the column I think that needs to be dropped are these. They don't really add anything to this data. This column, I need to remove survive ID, because if you go back and you check your data, you can see if you check survive ID, it's not adding anything to the data. It's not going to give you any information. You see, survive ID, the village, this. So 1, 2, 3, they don't really add anything to the data. So day of the week, the day of the week that the survey was conducted, doesn't really mean anywhere, except you want to check the mood of people during the particular day from Monday to Friday, and you want to check maybe depending on your objective. If my objective is to check how happy people will be at weekend or during the day of the week is going to be good. But for this data, it looks like something named depression, and it may not really add anything to it. It's a long time stuff. So it's not just a day. You cannot just be because you are depressed today and now give all this data this way. They are asking you, are you married, or the age, the number of children, the education level. So these have more meaning to being depressed than the date it was. I can't say because it was Sunday and I will now say I'm female today. Then tomorrow is Monday, I will now say I'm male because I'm happy. So I can't be telling you that my age is 60 today, and tomorrow I will now say, okay, because it's maybe today is weekend, and tomorrow is weekend, okay, I'm now 30 years old. I can't be telling you that because today is Monday, I'm married, then Tuesday or Wednesday, I'm not married. I can't be telling you today I have 5 children, and next tomorrow I will say, and because the survey was taken on Tuesday, no, okay, I'm having 1 children, or 2 children rather. or one child. I can say my level of education today is 5, and tomorrow I will now say the level of education is 20, based on day, because it was Monday to Friday. So that is not going to add anything to the good information to that. But apart from that, the other thing I copied now, I can't remember again. I just copied from here that I want to drop. I want to drop one of them. So let me go back to it. I copied, okay. I want to drop this as well. So let's drop them from our data so that even the data itself will reduce. The number of columns will reduce from 75 to maybe 70. So let me drop it. They are irrelevant data. Let me drop all of them. And is there anything you think we should still drop that should be irrelevant? As for me, these are things I think I can drop. So let me drop it. Drop. What is wrong, man? Incomplete input. What happened? Did I not close anyone? Okay, yeah, I removed the close. Okay. What again? Do you see any error? Check the error for me. Not found in ASICs. Survive, village, survive days, date of the week, HH total. What is not found? Okay, maybe there's any one of them that already have a space. Is there any one? It's not found there. None. They have the drop. I want to drop all this, and it's telling me not found in the ASICs. Okay, I didn't put where I want to drop it. I didn't put ASICs is equals to yeah, I didn't put it. Thank you. I didn't put that is going to be in the, of course, I told you the other time why I was teaching that we have to tell whether it is from the column or from the row, and we have to set the axis to be equals to 1. Yeah, I believe you can still remember that. So, and the same thing is happening to us again. So the axis is equals to 1, telling us that this is column and not row. Okay. Let me just delete this and rerun that. Run.
Sorry, okay.
Yeah?
So I have to drop off now.
Okay.
Yeah. Is that okay?
No problem. You're welcome.
Yes.
Yeah. So now let's quickly see the head again now. The F should have been reduced, and we have all these things removed from our dHEF. Okay. So the axis has been removed from our dHEF. If we check, we can check for dHEF.x so that we can easily see that dHEF.head. Again, to just see the first 5 to see that you can see every other thing has been removed except the 5 has been removed, and we now have a lesser column. The next thing we want to deal with is, of course, from our info, we see that some of this data, they are supposed to be converted, or even before then, we can remove the NA. Let's check for NA. Of course, we already know we have NA. Let's check for NA, checking for the missing data. At checking for the missing data, we already know how to check for that. Let me just copy the code to help us. And I put the code. Yeah, we want to check for the missing data. Of course, we know that there are so many methods we can use. We can use the heat map to quickly check for the missing data. And doing this, if we have it dense, okay, it's telling us that there are a lot of missing data here. When you check on corn's whole food, when you check on corn's main total, there are a lot of missing data there. When you check on these, on all these, there are lots of missing data there. Then we can as well, of course, this is just a visualization to tell us that we have missing data here. Of course, we already know if it is the same thing throughout, like purple throughout, the same background throughout, there is no any other color, it means there is no missing data there. But now, since we have a missing data, we can even check the numerical values using this method. We just add them together to see the numerical one. I sum them and I make them to be alphabetic according to the maximum. The first one we have here is FS whole offense. So which is having oh, it's not even the first one. We have a lot of them. Okay, the first one here is net under 5 depth, which is 1084. So it doesn't worth it. I don't think this worth it at all. We just have to remove this again from even, we don't need to input anything here. The data is not good. We cannot, out of 1,000 and 1,000 plus, we are already having 1,000 plus missing data from it. So which shows that that column is as good as no column, in my own opinion. So I will prefer we remove it. This made us, well, we may feel for the remaining one, but this one, I think we just have to remove it. So what did you think about that? Hello?
I kind of agree since it's not going to have any impact
Yeah.
on the analysis.
Is out of 1,000 plus data, we already having 1,000 plus missing data there. So we show that it's not a good one. So we just have to remove it. So now, if I'm thinking we should remove that, then we're still going to use the same process we used to remove from the above. So you just copy this, but this time around, what you want to remove from your data is that first one. Of course, you have to clean up this place and put the data. Doesn't necessarily have to be in there because it's just one, so you don't have to put it as a list. So I want to remove this data. It's not a good one from my, let me just remove the column. That column is not good at all. So if I remove that column, now I can now make imputation. Okay, I didn't put what do you call it? Yeah. Yeah, run. So now the other thing I think I can do here is to just try to input for this other one. For this one, if you check it, it may be the main that will be the best thing to do for this. For this one, it may be the mode. For this one, it may be the main, like that, like that. So let's just use fill, main, and mode to, you can go and check the data later. You will know the best to use for it. Now, but from my own hand, while I was going through the data, of course, the data has been given to us since last week, and we were all had to go since Sunday. Yeah, I think we all have to go and look into the data. So if you look at the data very well, best method I think that will be the best to fill them is what I use. I want to fill. Now, of course, I already removed this, so I don't even have that one in my data anymore. So, but when I was checking it, I used this method for this particular column, I fill with mode. I think mode is the best thing that I should use to fill this particular one. So when you get home, you can check on that. So I want to fill this one with mode. So if I run it, it's going to fill all these columns. Of course, those columns, consume alcohol, all those stuff. If you check that very well, all of them are here. All these consume alcohol, all those ones that is having 43. It's not because it's having 43. I actually went to check the data. Some are one, so I look at it, and some it is best to use some of them. It is best to use median mean. Some is best to use mode. Some is best to just fill it with 0. So when I checked everything, so that was what I did. So when you get home, you can go back and check those one. And if you think mean is not the best, then okay, I use mode for this. So if you think mode is not the best, then you use mean to fill for it. That one now depends on your own understanding about the data. And for this one, I decided to fill with 0. I use 0 to fill them. Maybe because I just feel like, okay, if you go and check the meaning of this, and go and check the meaning of this, you will see that it may be best to just fill them with 0. So when I check them, I fill them with 0. Of course, you already know how to fill. So this is just the way on how to fill them with 0. Except for these columns in my data frame, fill them with 0. Fill NA 0. So you can check the data, and you see that this is the best thing to fill them with. At the same time, I also checked the last category of the data that I think I should use a median to fill them. So I use median to fill all this one. I fill all this one up with median. If you like, you could have just fill everything with median or with mode, depending on what you just think. So this is all I think, and I fill all these with main. So let me run. Okay, so all of them have been filled with main. So if I check back, if I now check my data back, because most of the time when you have done that, you can check. If I check, I should have another, if I want to use heat map to check again and see, anytime you have cleaned, you have done any of these cleaning, you remove and you fill, you should check back to see whether you still have something left or everything has been cleaned. So if I check now, I should not have NA again. You can see everything is now pure. It's pure green throughout. If it want to be pure yellow, it should be pure yellow, depending on the system you use at that particular moment. So if it's going to be pure purple, it's going to be purple throughout. If it's going to be pure green, it's going to be green throughout. If it's going to be blue, it's going to be blue throughout without any dent on it, which shows that all the NAs have been filled. You can see this is different from this first one. This first one is having, instead of it to be purple throughout, you now have some yellow on telling us that we have NA in all these places. Now, and you see in this one is pure. There is no any problem again, which shows that all the NAs have been filled. The same way you could, instead of using this, I could have called on this. I just call on this to check if, initially I was having all this stuff. If I call on that now, it's going to give me 0, 0, 0, 0, telling me that I fill all the NAs. Sometimes you may remove all the NAs, but in this kind of data, if you try to remove all the NA, you may just be left with 2 data. You may just be left with 2 rows, because the NAs are just too much. So you cannot be removing NA. You rather fill with mode, mean, media, or you fill with random number, or of course, I also said we can use interpolation, but in this case, we can't use interpolation because this is not a time series data. So you can see all these things now become 0. You can see everything. There is no all of them. They are 0 now. So we no more have NA and A. Now, after we have dropped the NA, now we have dropped the NA, what other thing can we do? The next thing we can do is to work on the data type. Let's see, check for info. The help.info again. There is no number of time to check all this. So you can check as many times as you like. So if I check for the help.info again, now we are saying some of these data type, they are mismatched. So, and one of them is age, that is supposed to be, age should not be a float, it's supposed to be integer. So these are the mismatch, this is just the one I can decode now. But yesterday while I was going through the data, I saw some of them that, let me just copy those that I saw that was mismatched. Yeah, these are the one I saw. And I want to convert them to integer, okay? So if you go back and you check the data description, you will see that all the age is supposed to be in integer, is not supposed to be float. The this one, if you go and check, it's supposed to be integer, it's not supposed to be float. All these things are supposed to be integer. They are not, okay, of course, I've removed this from all these ones, they are supposed to be integer and not float. I have to convert them to integer. So let me run them. So everything should have been converted to integer now. If I run this again, of course, anything you do, you must always run to check again. If I run the info again, the age that was float before should have been changed to integer. All I did here was to take all the columns that I want to run and call and put them as a list. After putting them as a list, I'm now checking that if you have those columns, you see, that is this column, instead of calling them one after the other in bracket, in comma, and be saying the head, age, comma, something like that, comma, this, comma, that, comma, up to this place, comma, like putting all these things inside this place. Of course, I'm just trying to index them out. So I should just first put it here so that it's look neater. It's because it looks neater. So, but you can as well just put them in the container like that and put them in the square bracket and begin to put comma, comma, just copy everything you have here and put it inside this place, and it's going to be long. And as well, you can as well be doing them one after the other. Assuming you want to change them to different things, if this one to be changed to object and this one to be changed to float, you can't do it like this. You have to be picking them one after the other and do the head into the particular one you want to do. Let's say age is equals to, that is changes to, is equals to the head into that particular column, which is age. Oh, I didn't put it. Age dot as type whatsoever you want to convert it to. As type, maybe object. Assuming it's object, I want to convert it to, or maybe float or whatsoever like that. So you can do this. You can just convert to object, convert to integer, convert to float. So you can do it that way. So then you can as well, instead of doing this, you can as well just be doing this for everything. You do this for the first one, maybe you still want to convert. Assuming we didn't do the whole of this as one, you can be doing them one after the other and put your integer here. It's going to convert this age to integer. Then again, you do for this, you do for that, you do for this, you do for, so, or you use this method and say comma, as many as possible, as many you want to do, comma, like that. So, but This is more optimized. So, let's call for our info again. The help.info. Let me just put let me add more column shell. The help.info. So the age and every other one should have been converted. If you go back and you go and check your age now, you can see the age is no more float, is now integer. And the same thing, if you go and check all these med, health, consult, should have moved from the previous data type to the present data type that you have converted it to. So it is assumed now that all the NA has been treated. The NA has been treated. Let me NAN treated. After that, data type treated. So there is another thing we can do. If we go back to all what we are supposed to claim, okay, it's not here. We say we can do drop. We have dropped the unnecessary data. We have checked for the missing stuff, and we have changed it. Another thing we can do, we can rename any column we think we want to rename. We think it's not proper. Let's rename it. So if you think of anyone that you think we should rename, I don't know. If there is anyone we are supposed to rename, you should have known when you should know when you go through the data, or maybe by just checking the column. If we check the column, we call the help.column, the help.column. Oh. Column. Column. So these are all the columns in our data. When you run, if you check this, in fact, you can even see from the info all this column. You can see, and when you come to the data itself, you can see the columns. These columns, all these columns. You can see all these columns. So if there is anyone you think we should change, we should change. You don't like the way, like all this one, if you want to write it like this one is good age, or if you like, you can turn, okay, like married, or if you like, you can call it marital status. If those are things you want to do, you can easily do the rename. I talked about a method to do a quick rename. Maybe let's just do a quick rename here. If I want to do a quick rename, after I've done this, I will just copy the same thing. Just copy this. What you used to check for the name, you copy and paste. This is actually what I used to check for the name. And you say is equals to whatsoever name you got here. This is the name you got here. It's still the same thing. You just copy and you paste, but you are not going to copy the index and the bracket with it. So you say it's equals to this. You just copy it like a list. So I've copied everything. I just copy it from the square bracket to the square bracket. I say it's the same thing as the help.column. If there is anyone I now want to change, like I want to call this one marital status, or I want to change everything to capital letter, I just married, number, or maybe I don't know if this is number of children, number, or I can just say NO, number of children. I don't know what all these things mean. Then anything you want just to change, maybe instead of saying like this one, edu, if I like, I can call it education or level of education. I don't know. Level of education of edu, like this. If there's anyone I want to change, I don't know. I don't know. So you just check anyone you think Okay, maybe I want to change this one to maybe I want to change everything to, oh. Just ensure you don't make mistake. Okay, you don't delete what you are not supposed to delete. Just manipulate anything you think you want to manipulate. After the manipulation, all you just have to do is to run it. It's going to automatically update your data frame. If you call for the data frame again now, it should have updated everything that we have changed. If I just say the head, call for it, it's going to tell me, okay, let me just call the help.head so that you just see only the 5. Okay, oh. The help.head. So it means the head, you can see, married, I change it to capital letter. Number, okay, this number of children is not even good enough. I just say, okay, if I like, I can put iPhone. This one I put level of education. You can see the one I change has actually changed. If I want, assuming I change this F to capital, this one will have changed to capital. So I can still go back. If there is anything I think I've changed that I don't want, I can just go back there and manipulate, like maybe this age. Just the age, the number of children. I don't know the way I don't like the way it was written, so I can put it in Ivan. So this one, maybe I don't like the way the level of education was written. I can put it in Ivan. Then I run again. After I run it, I go back again and go and run that the head.f. All the changes will come. You can see female, age, married, like that. So I can actually make it more neater. So these are one or two things we can do. So now this data is now free from NA. We no more have NA in the data. It's now free from, okay, the mismatch stuff has been done. Now, another thing we can do is to check for, okay, let's go to the layout we are using. We have renamed, we have checked for the data type we have changed, we have handled the missing data. Then is to check for the outliers. So if you are checking for the outliers, there are different methods of checking for outliers, which we treated in our last class. Some of the methods we say we can use bus plot, we can use so many other things. So now today, let me quickly just go through a bus plot. Assuming I want to use a bus plot for this particular data, let me just copy a code for a bus plot that we can use. And our time is going. I don't know when it's time. We just have to stop and continue from where we stopped tomorrow. But before then, I think we can quickly go through a bus plot. Yeah, let's use a bus plot. So, but before then, there are other things we can still do. We can check a categorical. We separate if we have a categorical data from before then, let me quickly look into this. Let me quickly explain this. There are two forms of data we can get. We can have in our, there are two forms of column we can have in our data. These are the numerical and the categorical data. For example, if you check marriage, assuming this marriage has not been made to be a dummy of 0 and 1, we should get something like yes or no, or married or not married. We should get something like that. So this is going to be a categorical data. So it is during when you want to do your model that you change it to domain like this. The data is not supposed to come in this domain form. Let me check if there's anyone that comes in a categorical form like that. Everyone, they have actually helped us to convert this to a domain form. If if not, some of these things are supposed to be something like yes, no, and things like that. Like all those ones that are 1, 1, 1 stuff, they are supposed to be yes and no. So if we have data like that, we have a way of dealing with them. But since we don't have, we leave that till when we have a data that contain an object. You can see if we check our info here, all the info, they are having float and integer, float and integer. It means all the number, all the data we have here, they are the type of numerical. There is none that is non-numerical. So if all of them are numerical, then we can actually work on them using what do you call it? I'm trying to use a bus plot. So let's use a bus plot to check if there is anyone that contain what are we dealing with? That contain I'm trying to look into what was I trying to look into? If there is anyone that contain outliers, that is what I want to remember. Thank you. Outliers. And you know what outliers mean? Outliers is just number unusual data in our column. Outliers, okay? We say we're gonna, let me just copy the code. We say we're gonna look into the outliers. So let me just, instead of typing again. Now we want to deal with our outliers in our data. This is what we have done. We have claimed the NaN. After that, we do the data type, mismatch data type. Those that are supposed to be integer, we put them back to integer. After that, after we've done the mismatch data type, the next thing we want to do with outliers. So before we can do anything, before we can continue, we must treat the outliers. What is outliers? The unusual data in our data, the data in our data set. I have been citing the example of students that are supposed to be in maybe in year 10. And if students are supposed to be in year 10, you are not expecting like 30 years old to be in that class. So any 30 years is going to be an outlier. And you are not expecting someone that is just like 7 years old to be in that class. Then if you get anyone, it's going to be an outlier. So how do we check for outliers? These methods can be used to check for outliers. But I don't want to use it this way, because by using this way, I'm checking for everything in the column. I can say for column in data frame, the help dot column, I want to check for all the columns in the data frame. And I will say, if you find anyone that contain, okay, draw a plot which is called bus plot for all the columns. Draw a bus plot for all the columns. So, and this is how to plot a bus plot. Later, you're gonna understand this better when we get to visualization. Bus plot is one of the visualization that you will need to understand. But for the purpose of this cleaning, let me just quickly tell us how to plot a bus plot. The bus plot is just one of the charts that you can plot using your Seaborn. And you will see when we're importing our Seaborn, we said SNS. And the column where we say check the column for every column for columns in the help.column. But if you think this is going to be too much, you can as well just pick a particular column. For example, this is the column I want to pick. I want to pick the column of the age. You can just plot for one and be plotting them one after the other. So I want to plot for age. Is there any in age column? I don't know if it's capital A now. I don't know that I use. So in the age, if there is any in the age, plot the bus plot for this age. You can as well just run it this way. If you run, it's going to plot. This is the bus plot for the age. This is the bus plot. The every other thing you have here is like just labeling other stuff. It's not necessary. This is the only thing we need to plot for the age. So this is the bus plot for the age. Normally for this is the lower part of the age, while this is the upper part of the age. You will see we are having two tails there. In the age, we have two tails. The upper tail, the one that goes up, and the lower tail here. Now you will see at the lower tail here, there is nothing like all these. There is no any other figure. There is nothing, you can't see any other data like this at the lower part. He's telling us that we have some people at age 70 to age 90 that should be treated as outliers in this data. So this is the age, and we have some people that is age 70 to 90. But yeah, it's actually starting, there is no one that is less than 18. If you check this data very well, it's like there's none that is less than 18. That is why, and it's making it like 18 is the least we are expecting, and the mean age we are expecting is going to be the middle of this, with about maybe 30. It's setting the upper boundary and the lower boundary for this. So setting the upper and the lower, and majority of the people are from 30 upward. So we have more people at this 30 upward. And then after the upper boundary, setting this at the upper boundary, maybe at around 65 or something like that, every other people after this are said to be an outlier. So you can see these are said to be an outlier. So you can check for everything. It is better for us to understand. Sometimes you may not actually understand outliers in some other columns. So, but let's run for all the columns. Instead of running them one after the other, we decided to use this method, the one we have here, to check for the whole column from A to Z. So let's run it. Let me just copy it and run. This one only check for age alone. We are saying, what about if we want to check for everything without checking them one after the other? Though sometimes checking them one after the other is the best. So let me run. So it's checking for all the columns. Okay, it's checking for them one after the other, and it's running them. Any of those columns that contain this, something like this, is going to be said to have an outlier. Towards the tail will be said to have an outlier. So that is how to check the using bus plot. So let me just go up to the beginning. Oh, it's a lot. It's plotting for about 70 bus plots. Some of them you will not be able to understand it, because if you don't understand what the data actually represents, you may not be able to. So you will have to go back to the data and study it very well, know what each columns represents. So see, let me just push this one up. Okay, this is the starting point. box plot for, okay, it's saying female, male, and female. This one, we cannot be talking about outliers there anyhow, anyway, because it's only going to be male and female. So, and you can see everything is just skewed because it's just one and it's just 0 and 1, 0 and 1. So you cannot actually get much from here. Okay, this age, this is for the age. Of course, in the age, you can see that here we have in this age, you can see that we have at this tail, the upper part, we have much of the upper limits. So more outliers there. So here, this one, married, of course, this one is just yes or no. So you don't really have much here. Okay, this one is not really having much outliers. I can only see 3, so just 3 children. Okay, it's like some people are having 10 children, 8 children, which is an outlier. So it's expecting that your child, okay, is it value? Number of children, okay? So the number of children, 6, so should not be more than 7. That is only 7, setting 7 to be like let's say, okay, and the mean children should be about 3. Number of children expected, like many people should have about 3. 4 is still good, and of course from maybe from 1 to like 7. But when you begin to have 8, 9, 10 children, can be said to be an outlier. So how come you're having 10 children? Of course, you may not be able to doubt this. You may not necessarily have to treat it as an outlier. So you have to understand the data very much. So this is how to check. You'll be checking them one after the other. The number of people in an household. So if these people, we are having 12 people in an household, is too much. And it's expecting that in an household, it should not be more than 10, like father, mother, and like 8 kids. So that was why it's setting something around 7, like the number of children you can have. And of course, if you have it plus father and mother, should be about 9. So I don't know, but I think it's setting 10 here or 9. I don't know. But just like, I think all these are still okay. These are how to get the outlier. So this one is having both upper outliers and lower outliers. So if we are saying you're having the level of your education is 2 points, I don't know what 2.5 represent. If your level of education is less than 5, maybe these are the people that finished primary school. I don't know. These are the people that only went to nursery school. And after that, you now have people that are above, maybe, I don't know the standard that have been chosen for the level of education. So if your standard is now more than 12.5 or maybe at like 13, maybe 13 is like a PhD, and like 15 to 17 is going to be post-PhD. Like, oh no, you don't actually have to do much of this, or it's going to be an outlier. So these are the number of people that were set as outliers at the upper part, and these are the data that were set as an outliers at the lower part. Because of our time, we cannot go beyond this. In our next class, we will continue from these outliers and then maybe move to data visualization. Thank you for your time.
Thank you,
Thank
Abdul.
you. Thank you so
Thank you,
much.
Abdul. Have a good night.
Yeah.
Thank you.
Thank you.
Yeah.